Welcome back to Docker for Developer series. So far, we have learned what Docker is and how Docker architecture works. We now know that Docker daemon creates containers from images. But this raises an important question. What exactly is a Docker image? And how is it different from a Docker container? Many beginners use these two terms interchangeably, but they are completely different concepts. In today's video, we will understand this difference using simple analogies, examples, and real world scenarios. Whenever someone starts learning Docker, these two terms appear everywhere, image and a container. People often assume they mean the same thing because we usually create a container immediately after pulling an image. But think about it this way. An image is a blueprint. A container is something that is actually running. By end of this video, you will never confuse these terms again. Imagine you have a cake recipe. The recipe tells you what ingredients are needed and how to prepare the cake. Can you eat the recipe? No. You must use the recipe to bake a real cake. Here, the recipe is like a Docker image. The baked cake is like a Docker container. You can bake many cakes from the same recipe, just as you can create many containers from one image. If you are a Java developer, here is an even better analogy. A Docker image is like a Java class. A class defines the structure and behavior, but it doesn't execute anything by itself. When you create an object using the new keyword, you get a running instance of the class. Similarly, a Docker container is a running instance of Docker image. One image can create many containers, just like one class can create many objects. A Docker image is a read-only package. It contains everything required to run an application. This includes your application code, the Java runtime, required libraries, dependencies, configuration files, and even the operating system layer. An image doesn't execute anything. Its purpose is to act as a reusable template for creating containers. A Docker container is a running instance of an image. When you execute the docker run command, Docker creates a container from the image and starts it. The container has its own process, memory, networking, and writable layer. This is the component that actually runs your application. One of the biggest advantages of Docker is reusability. Suppose you have created a Spring Boot Docker image. From that single image, you can start multiple containers. Each container runs independently. If one container crashes, the others continue running. This makes Docker ideal for scaling applications. Images usually have a long life. You build them once and reuse them multiple times. Containers, however, are temporary. You can start them, stop them, restart them, and delete them whenever needed. Deleting a container does not delete the image. You can always create a new container from the same image. Let's look at a practical example. You create a Spring Boot REST API. Using a Docker file, you build an image. Now, whenever you execute docker run my-app, Docker creates a new container from that image and starts your Spring Boot application. The image remains unchanged and can be reused again and again. Let's summarize the differences. A Docker image is a blueprint while a Docker container is a running instance. Images are read-only templates. Containers have a writable layer where runtime changes occur. Images are built once, but containers can be created many times. Interviewers frequently ask these questions because they reveal whether you truly understand Docker. So remember, an image cannot run directly. A container is created from an image. One image can create many containers. Deleting a container does not remove or affect the image. Let's recap today's lesson. A Docker image is a reusable blueprint containing everything your application needs. A Docker container is the running instance created from that image. You build an image once, but you can run many containers from it. And now that you understand this difference, you are ready to start working with Docker in practice. In next video, we will install Docker on Windows, Mac OS and Linux and then run our very first container.